Recording has started. So good morning, everyone. We'll go through lead code daily session today. We have 3 questions and I haven't solved any one recently. So hopefully you guys will help me to go through the problems. Let's start the session. So the first problem for today is implement queue using stacks. The operations we have to implement is push, pop, peek, and empty. And here is example where first we are pushing 1 and then 2. So when you peek it, it should still show me 1 because in stack, whatever is like it's like LeFo structure. So you should maintain that basically. And then when you are popping, then the guy actually, sorry, it's the other way. It's a queue, so we have to maintain FIFO structure, but we have to use a stack to use that. So when we are peaking, we inserted 1 and 2. So first 1 was inserted, so you want to return 1. Same with pop and whether queue is empty or not. So in this particular case, we will still have 2 there. So it will return false. Okay, and these are the notes. All right. So has anyone tried solving this problem? Any ideas? So you have to implement queue and you can use a stack. That's the question basically. So a queue looks like this. So for example, you pushed 1, push 2, push 3, things like this. And so I am pushing in this order. So first I pushed 1, then 2, and then 3. So I should get things in this order. But you have a stack. So somehow you have to use a stack to implement that thing. So to do this, using this structure, what will you do? Like, any ideas? Did anyone solve it or not? Because I saw a couple of people check mark that they are solving, and this is also a very old and famous question. So I'm pretty sure you guys have, some of you must have definitely solved it. So come forward.
Yeah, I did that.
You can, yeah, go ahead.
Yeah. So go ahead. Like, let's go through this. Like, how do we solve it? We have a stack, but we can't use queue.
You can use 2 stacks then.
I can use 2 stack. Okay. So I can use 2 stack, but what was the reason that I'm thinking that I should use 2 stack?
Because the way the queue works is whatever you insert first should come out first. Your 1 should come out first, right?
Right.
In stack, your 3 is going to come out first. If you take just 1 stack and you push all your elements in it, 1, 2, 3. But
Exactly.
if you use another, you can use another stack to push all, you empty your first stack, 1, 2, 3, in that other stack, stack 2. So now your stack 2 will look like 3, 2, 1.
Right. So what you are saying, the same thing I will say that when you put the stuff in stack, it basically reverses things, right?
That's correct.
because when you pop out, you are now getting the last guy. So if we reverse anything 2 times, basically we are canceling out.
Yes.
Reverse of reverse just canceled out. So that's the intuition. So using that, definitely we should be able to solve it. So now the question is, okay, to push, what we will do, like let's simulate mm, some examples. Like first we start with 1. So this is my stack 1 and this is my stack 2, for example. So 1 came. So you are asking me to put in 1 S1, right?
Yes.
Okay, let me put here. Then suppose S2 came, like 2 came. Should
Mhm.
I still insert here?
So the way I implemented it was I was putting everything in stack one, pushing, and then updating stack two.
Oh,
That's
okay,
how I implemented it. It's not the best way, I know, but
that's fine. We just want to get one solution to start with. So you push 2, and now
yeah.
suppose, like, before pushing 3, somebody asked
Mhm.
me that like pop, like, give
Mhm.
me the
Yeah.
pop value.
Yeah.
So what will you do then?
So I was pushing everything in S2 and then popping out.
So you said
That,
remove from here, and then you pushed it here,
yeah.
2 and 1, and then you popped this guy.
Yeah.
So
That's
you
how I was.
returned 1.
Mhm.
Okay. And then did you change the name of S1 to S2, or you again started pushing this to here?
Pushing back. Every time I push it to S1.
Okay.
Yeah.
Yeah, that should work. That is, like,
Mhm.
one approach which may work. But
Mhm.
the thing is, again, you yeah, like somebody can see the optimization here. Like, question is solved
Yeah.
for sure.
Mhm.
When we are now moving to again in this stack, maybe we know that we are going to put stuff uh, again in this queue, and here in S2, as long as we have some element, we don't even need to, like, like, move from this side to this side. So this queue is actually giving you, like, if you already have item here,
Mhm.
it is telling you, hey, you can pop from here. We already have some items which were inserted earlier,
Right.
right? But yeah, if this is empty, if this guy is empty for sure,
Mhm. Mhm.
then it makes sense that, okay, now just, like, get stuff from here and push it here. You can make that optimization. Anyone has any other idea or question on this idea?
Can you come up with like an example? 1, 2, 3, 4, 5, 6.
Yeah, sure.
Like just like maybe with like few more elements to make it more clear.
Yeah, sure, we can do that. So we should call the APIs with some values actually, so it will be
Yeah.
more
Let's
clear.
say push 1, push 2. Sorry, like it's a queue. So what's the API on the queues that we are
Yeah,
given?
they are calling push, so it's fine. Otherwise, you can say in queue, DQ, but let's call push
Okay.
1,
Push 1, push 2,
push 1, push 2,
pop,
pop,
and then push 3,
push 3,
push 4,
push 4,
pop,
pop,
and then pop pop.
pop, pop. Okay,
So it should give me like in the order 1, 2, 3, 4.
yeah. So
It
what's
should
yours?
also include peak.
Yeah, we can also include peak, and we can also include is empty, ideally, right? So let's say here before pop, I said peak. Just after pop, I called peak, and then I said pop. Is that fine?
Yeah.
Okay. So what she was suggesting that we'll have one stack to begin with, two stack. So she started putting stuff in stack one. So in stack one, you have one, and in stack two, nothing is there so far. So this happened, and then we did this operation. Then push two, then she said like, okay, let's put it here. Now this operation is pop. So during pop, what he is suggesting, C will empty this guy,
So what if I call is empty right now?
right?
Before
So
pop is empty.
let's call is empty. Is empty. What do you guys think? Like we have two containers and we are going to use both of them. And somebody is asking you, is it empty? So what will you check? You should check both, right?
Both the stacks, yeah.
Right. So we will check whether this is empty and this is empty. If both are empty, then definitely it is empty. Otherwise, it's false. So that API can be solved like that. So this is done. Now we'll go through pop. So pop, what she was suggesting that we will pop elements from stack 1 to stack 2. So 2, 1. So we will have nothing here. So this is empty, right?
Yeah.
Okay. And also pop returns a value. So we'll return 1 here, right? And then this guy will also go out. This guy will go out. It's not there anymore. Okay. So now what? Next is push 3. Push 3 is, so where do we want to push it? So we are going to push it on stack 1, right? So we did push here 3. Stack 2 is containing just 2 and stack 1 is containing 3 at this point of time. Push 4, we are putting here 4. Now we are going to pop. So the rule is that I have already filled my container to pop elements. So if there is anything, I know that those guys came earlier. So it will always go and first check stack 2. So it checked, is there anything in stack 2? Yes, there is. So it will just return 2 here. And at this point of time, stack will become empty. Then the thing is peak, right? So in this particular example, what we will do? Peak means like,
So like let's also include peak after push 4, just to clarify it.
yes, that's a good idea. I was thinking the same. So you are saying that there should be a peak here, right?
Yes, just
Yeah, yeah, that will clarify more. So let's go to the previous state. So please assume that this 2 is not yet deleted. We are here, we just pushed 4. So we just did this operation and let me try to erase maybe. So our current state was, we had just 2 here, right? Nothing else. So now when we are doing this particular peak, which stack should I look at? Can anybody answer quickly?
First, it should look at stack 2.
Yeah, because we want to see the elements which were inserted or already there, because we want to see from this side. So yeah, we see, okay, 2 is there. So peak will return 2 right away, but it will not delete. Then we are going to do pop. So in pop, we'll again go through stack 2 because we have created this container previously, which already have some previous values. So let's continue to use it. So we'll just delete this too, pop it out, and then this stack became empty, by the way, stack 2. So here is another peak now. We will go and check stack 2, but stack 2 is empty. So now stack 2 is empty, then what should we do? Now, who is the next guy? After 2, 3 was the next guy.
Mhm.
So you are not going to just peek here, right? Because if you peek, you will see 4 here. So what you can do, yeah, please someone suggest what should we do here?
Yeah, push elements from stack 1 to stack 2.
Exactly. So now your stack will become here, you will have 4 and then you will have 3, right? Now this is gone. And then you will also, since it was a peak, you will return this value. So this peak returned 3 here. Now next is pop. So again, same rule, like if anything is on like stack 2, we'll just return that and delete from the stack. So 3 was there, so pop will return 3, and then again another pop, then you will again look at stack 2 and you will return it and pop it from there. And if stack is empty, you can add those checks, like if it is empty and someone is asking for pop, then just throw some exception, that kind of stuff you can do. That is one of the approach. So any question, anything someone wants to talk about time complexity, space complexity for this?
Hey Roger, I have a basic question.
Yeah.
I know when we convert one from one stack to another stack, we get the queue. I understand that. So what's the benefit of splitting the push operation and then popping? Like at the end of the day, it will give the same result. Like what is the benefit of doing this way, like the current way?
As opposed to which way?
The whichever we solved right now, like push pop push peak pop. Like instead of that, we just move one stack to another stack and do a pop. It will give the queue.
So your question is, like you're still going to use 2 stack, am I right?
Yeah, we are still going to use two stack.
Mm-hmm.
Like instead of doing push pop push, we directly
You are
we
going
don't need to, yeah, we don't need to pop uh, every push, right? So here, so in our current approach, how we did is we did a push pop, right? So
yeah.
instead of that, we can like push like till the end of the stack
Mm.
one. Then we pop from the stack two, it will give the queue.
Okay, wait a minute. So let me try to understand what you are saying. This was push. So
Yes.
let me erase quickly this thing. Let's go through what you're saying.
Yeah, just keep 1 2 3, that should be enough.
Okay, so this is stack 1, this is
Yes,
stack 2,
right.
and what should I do? So push 1 came, so what we are doing
So push one.
on
So in
stack 1?
stack, yeah, on the stack one,
Okay,
push two into stack one, push three onto the stack one.
so even if there is a pop, you will go and push this one. So there was a call to pop before the push 3.
Yeah. My question is, why do we need pop here? What's the
So,
idea behind pop?
so this problem was like, you are implementing a queue.
Right.
So these APIs are like, queue can be called in any sequence, right? So the user is calling push 1, push 2, and then pops and then push.
Okay.
So you are building queue using 2 stacks. So you can't push 3 because you don't even know about 3 at this point of time when pop was called.
Oh, okay. The order of function, the order of push pop will be in any direction. That's what you're saying. Oh, I don't know that. Okay.
Yeah.
Oh, okay. Okay, now it makes sense. Okay, got it.
Okay.
Got it.
Yeah.
Yeah, thanks.
No problem. So someone wants to talk about space complexity, time complexity.
We are using 2 extra stacks.
Yeah, we are using 2 stack. That's right.
And the maximum value should be the length of the stack, because the one of the stack can be completely filled, and so can the second be with all the elements. So worst case would be like O of n, like 2 stacks each of O of n, where n is the number of items that are being added.
Yeah. So space wise, like, it depends on how many elements we are pushing, right?
Yeah,
At one
yeah,
point of
right,
time. So if
right.
we define that as n, then overall it is still n, right? Because we will not duplicate items, right?
Yes, that is correct.
So space complexity is that. Then let me mute someone here. Give me. Okay. Now, time complexity. So time complexity, it looks like it's O of n, but is that the case always? Because when you are calling, if you remember, we were calling pop and stack 2 was filled already, like, because we just, you know, pushed bunch of stuff from this side to this side, these pops will become actually very fast, right? Because we are just returning item from the peak. So for pop, it's not always O of n. For push, if you remember, we are always putting on this guy. So for push, it is definitely O of n, O of 1, right? Because we are just going to put anything on stack 1 without thinking, right? So when this
Yeah.
kind of thing happens, then we start talking about amortized time complexity. So during such event, like, during maybe one call, it is possible you had 100 items on this and you had to move all 100 in one go to this. But that is like, worst case, like, and just one of those worst cases. But overall, you can call that amortized time complexity is still O of 1, even for pop. And that is how even like, this thing works, that array list and things which grows. So after a certain bound, like, they start with some size, suppose 2, and then you start putting stuff, then it will add 4. It will then, if you start growing this, it has no idea how many elements you will put in advance. So maybe it will add 8 more. So these kind of things are like, when you grow the values, it happens only few times sometimes, and then you can then start talking about in this kind of amortized time complexity. So that's how I think I would say that that's the time complexity. Any question?
So pop is not always O of 1, right? Because sometimes we have to push elements from stack 1 to stack 2.
Exactly. Pop
Yeah.
is not always O of
Mm-hmm.
1.
Okay.
So when you will say like, but also pop is most of the time O of 1. Is that true or not?
Yeah, like once we have already pushed elements in S2, yes, then it will be pop would be off 1 for those elements.
Yeah. So for those kind of cases, this thing comes in picture.
Okay.
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 All right, guys. Anyone has any question, or should we move to the next one? Looks like it's okay. Okay, how to go to the next one? Like this. Stop sharing, and then next problem is basic calculator. Okay, implement a basic calculator to calculate, evaluate simple expression using plus, minus, multiplication, division. So for example, 3 plus 2 into 2 is 7, and then 3 by 2, okay, it takes a space also, so that means you have to ignore those. And then 3 plus 5 by 2 is this. Okay, all right. Any ideas, guys, for this question? If somebody has solved, please suggest. So question was like, one of the example was 3 plus 2 into 2. This is definitely 7. This is given you as a string, and you have to return that. So, and the operators you have is plus, minus, multiplication, and division. So what if the question is just plus? Like if you have to just do this, 3 plus 2 plus 2. How would you calculate that?
Use a stack.
Okay, we can use a stack. So how would we use the stack? If like, should I start reading from left side, the like what I just got, right?
Yes. Yes.
So let's have this stack here for some time, and I start reading this. This is 3, but this could be 30 as well, right?
Yeah. So you start reading up until we find a operator.
So let's call it actually 30. That's much better. So okay, we started reading it.
Reading the characters.
Mm-hmm.
Okay, so first character is a digit, so we find 3.
Mm-hmm.
Okay, then next character is 0,
Mm-hmm.
which is again a digit,
Yeah.
and our previous one was 3. So
Mm-hmm.
3 multiplied by 10 plus 0.
Okay, so we started with 0, and then we did like we found 3,
Yeah,
right?
so 0 multiplied by 10 plus 3.
So first we had 0 multiplied by 10 plus 3.
Yeah.
Now, yeah, we have 3. So 3 multiplied by 10 plus the current element, right?
Yes, it gives me 30, and then I go next. I found a operator.
Mm-hmm.
Okay, so I know like I'm done with the digit.
Mm-hmm.
I will push that digit onto the stack. So
Okay.
30, I will push it onto the stack.
Okay.
Okay, then if these are like just plus symbols, okay,
Mm-hmm.
then I move on to the next digit. I find 2.
Okay, you find 2. We will
Okay,
do the same logic here.
apply the same logic, push that onto the stack.
2. Okay.
Yep. Then again I found a plus. Okay,
Mm-hmm.
and then yeah, that's why I push it onto the stack, and then I found 2. Push it onto the stack because like the my string ended. Okay,
Right.
and at the end I will just pop everything from the stack and then sum those.
Okay,
Yeah,
so
but
like 2
in
plus
this,
2 plus 30.
Yeah.
yeah, but in
Yeah.
this case, if it's just plus operators, we don't even need stack, right?
Yeah.
Yes, we don't need it, but
Yeah, for
just
Yeah.
just this demonstration. Yeah.
Yeah, to simplify, we are going like,
Yeah.
you know, what we will
Right.
do. Now we will introduce minus to the game. So now, suppose if this was 30 minus 2 plus 2. So how would it go? So up to this, you already know. Probably we will push this, right? Now we have minus. So what should we do?
Yeah.
Anyone has any ideas? If we have minus now?
Though I have not solved it, but I'm thinking to have a two stack, one for the operand for the number and another for the operator.
Okay. So you
So
want to stack, you are saying?
yeah,
Okay.
so whenever I get a operator, I push that to the operator stack, and if I get the operand, I push to the operand stack. So now, when I see that, okay, now I do take care the operator precedence.
So you are having minus here, going to have minus here. And then you looked at 2.
2, then I push that to the operand stack.
So you came here, you pushed like minus sign here, and then you came to, so now 2 is done and you are moving to get a plus. So
Yeah,
before,
so when I get the second operator, then I check that what is on my operator stack top.
mm-hmm.
So based on that, I pull I pull from the operand stack.
So you will probably do this, and then this is gone, like empty basically. There's nothing here, right?
Not like that. I was thinking in a different way. I will just put the number only, not the sign.
Okay.
I'll just put the 2 in the operand stack.
Okay, you will just put 2. Okay, so let me
2,
make,
and I'll keep the operator as it is.
okay, got it.
Now I move to the next and
Mm-hmm.
get the next operator, that
Okay.
is plus.
Okay.
So we know that plus and minus both has the same precedence and from left to right.
Mm-hmm.
So now at this time, I will actually evaluate whatever I do have 2 element on my stack.
Okay.
So I'll push the pull the operator from operator stack and pull 2 operand from the operand stack and evaluate that.
Okay.
So at this time, I will evaluate 30 minus 2.
Okay, so what you did, I think, so you came to plus and you knew that plus and minus, whichever was on the top of this stack here, it was minus. So since they have the same precedence, you are going to pull these two values, right?
Yes.
And the first value you will apply this thing, right? Minus into 2, because this means minus 2.
Yes. So I'll evaluate 30 minus 2 and push the result back to the stack.
So you will say minus 2 plus 30. So, and then these were gone. And then now you are actually saying that, okay, so this means I have to push 28, right?
Yes.
Okay. And then, yeah, so that should work. What about multiplication?
The same way I will do the multiplication. So let's say, take an example, 3 plus
This
2
one.
into 2. Yeah.
Yeah. Yeah.
So let's push 3 to the stack.
So this is your operator. This is operand. So you put 3 here and then plus here,
Yes.
right?
Yeah.
And then 2 here.
2 here. Yeah. 2 to the operand.
Then you got a multiplication.
Then I got the multiplication. We know that the multiplication has the precedence.
Mm-hmm.
So I'll push the multiplication first.
So multiplication here.
Yeah.
Okay.
So I'll check that whether it's multiplication or what is the stack top. If stack top has the same precedence what the new operator has, then evaluate it. If the new operator has the precedence, then push it to the stack.
Right. So you are saying you will wait for this two to come now, right?
Yes.
So now this two came. So now, and we are like, at the end. So now you will again get two values. One was this two, which we just
Yeah. So
here
it will
made.
go to the stack, and then I start processing that. Pull two operand and pull one operator. Apply and.
So it came like this. You are done with this guy.
Yes.
Now you will start looking into this till we finally do all these operations, right?
Yes.
Yeah, that should work. Any question on this approach, guys?
So what if the precedence of any operator is lesser than the, like for example, we have a plus and multiplication, like on, it would be 3 multiplied 2 plus 2. So plus has less precedence than multiply.
So the question is 3 into 2 plus 2, right?
Yeah, so here we need to solve 3 into 2 first.
Yep, so here
Yes.
we pushed 3 here, then multiplication came. So multiplication came, then we got 2. So now when 2 came, we'll look at next guy is plus, right? But are we going to make a evaluation right here?
Yeah, so now we know that the next operator has the lower precedence. So first we will evaluate it, whatever we have.
Yep. So
does the input allow the parentheses, like group the operation by precedence?
so we are not allowing bracket if that is your question.
Okay.
Yeah, because that will be like, I think this calculator has different versions, so we'll go through that problem someday. But yes, so that should work. So is it clear? 6, now we have 6 here, and then my operator, this guy is gone already. Now we put plus here, and after 6 again we will get a value 3 into 2 plus 2. So this one has 2, and this value is plus. So next thing is again we will pop out. So we will have 8 here.
Okay.
Also, like, since we only have these two operations, multiplication and division, you can not even check precedence as such. Like, if you see, like, it's still precedence check, but the thing is that multiplication and division, they will be operated on two operands before actually handling plus and minus. I'm saying, like, we are doing the same thing, but we are not like checking that implicitly. Like, I know that minus multiplication, if I have to multiply 3 items, I can keep multiplying these two. So this will become 6 into 3, and then I can keep multiplying. So this is 8. Even the division, 2 into 3 divided by 4, is exactly same, like 2 into 3 is 6 by 4. So, like, there is no problem with, like, this and this check. You can do it in any order. Is that right? In this problem, I don't know how they handle division and multiplication, by the way.
They have like the same precedence.
They have the same. Okay.
So let's say if you have like 1 divided by 5 and multiply by 5. So if we do 1 divided by 5 first, it can be 0, right? And we multiply by 5, it's gonna be 0.
Exactly. So that was my question, but I think this problem is going to give you whatever came first. You can check, like, in the lead code, put this value and get the return. So 1 by 5 is, you are saying, is 0, into 5 is 0. if that was not the case and it was 1 into 5 divided by 5, then it would have been 1. That's your question, right?
I believe
Yes.
like we can assume that all the calculators
Yeah.
treat the numbers like I say decimal numbers. So they're like not integers for the calculators. So we will never get 0. 1 divided by 5, it should be point whatever 2.
Yeah, but here we do integer division, right?
Yep.
In this particular problem. So yeah, unless you start applying bracket.
Is it like mentioned that we could?
Yeah, if somebody has this open, try to put this value and see the output.
So it's written that answer is in integer form.
Yes. So for this value, what it returns? 1 divided by 5 into 5.
It should be 1.
It should be 1.
So which 1 by 5 or it should be yeah, it should be either, yeah, it should be 0 then.
So 1 by 5 is 5. Okay. Okay, actually third example was like that already. We didn't look at it. Like 3 plus 5 divided by 2 is 5, which is fine.
But I guess like even if they're integers, it should be all right, because when we evaluate these expressions, since the multiplication and division have the same precedence,
Yeah.
Whatever is coming first, going from left to right, will have the precedence.
Right.
Yeah, it is 0. I just checked it.
This answer 0.
Okay,
Yeah.
then it's good. Yeah, that's
Yeah.
what I was thinking. Good.
Yeah.
All right. So this works, and this is also a very nice way to solve it, because then you can, like, handle other precedents, not just multiplication and division. If something comes with more higher priority, you can change your rules accordingly. Anyone has any other ideas, or we are good for we can go to the next one?
I have like another approach, like where we can solve using a single stack.
Okay.
Did we talk about that?
We haven't talked about it.
Okay. Like, so do you want to like have some space here?
Yeah. We'll totally make a space for this.
Like take any string.
3 plus 2 into 2, maybe same thing.
Yep. And maybe plus after that plus 5, let's say.
Plus 5. So this should evaluate to 3 plus 4 plus 5, right? So,
or like let's also do one thing, like instead of 3 plus 2, like do 3 minus 2.
yeah, that's even better. 3 minus 2. So 3 minus 4 plus 5. 4. Okay.
Okay. So the idea is, whatever the string is given to us, okay, we can append a plus sign to it. Not append, like prefix a plus sign to it. So
by default everything is plus to start with.
Yeah. So this is like, just if you want to write it, this string will become plus 3, plus 3 minus 2, and then multiply, then 2 plus 5. Okay. We don't need to like prefix it, but we can assume. Okay.
Right.
Now take take a variable called operator. Okay. That variable will start with plus, like initialize it to plus. Okay. And then have a stack.
Okay.
Now we will figure out the first digit, which is 3. Okay. Now since we have initialized the operator as plus, we don't need to prefix it with plus. That was just for understanding. Okay. So we have an operator as plus. We find the first digit, which is 3. Okay. Then that digit and the current operator in hand, which is plus.
Yep.
Okay. Multiply
these two.
Like if it is plus, insert plus 3 on the top of the stack.
Okay. So plus 3 on top of this.
Okay.
So we are here at this point of time, right?
Yeah.
Okay.
Okay. Then you got a second operator. Okay. Update the operator that we have. We got minus. Okay. Then find the next digit, which is 2. Okay. that digit is 2. So we will multiply 2 by -1 and then put -2 on top of the stack.
So we are here. Our operator is this, and this digit was 2. So
Yes.
you said put minus.
-2, because we can compare, okay, like what the current operator, if it is minus, we will multiply that digit by -1 and then put it on the top.
Right.
Okay, then we got the next operator as multiplication. Update the operator as multiplication. Okay, then we find the next digit, which is again 2. Okay, in this case, as soon as like we find the digit, we will pop out the previous digit from the stack. Okay, -2 is popped out. Right? And with the current operator, which is multiplication, it is multiplied by the current digit, and -4 is pushed onto the stack. -4 is pushed onto the stack. Okay, then we find next operator, which is plus. Okay, we find next digit, which is 5. So again, as soon as we find the digit, use the operator and put +5 on top of the stack. Okay, now this is the stack like which we will get in the end. Just sum all the elements on the stack.
This works. So this is a very good approach, and the intuition behind this approach is that if it was plus or minus, they are.
Hello.
What happened? Hello? Sorry, I heard some voice.
Yes.
But the intuition is plus and minus are unary operator, right? You can use it as a just by itself. And what now we are trying to do, that trying to convert minus, like multiplication and division, two of those to one unary value. So eventually you are trying to normalize that multiplication to some either plus or minus. And if we already talked about this approach to begin with, that what if you only had plus or minus? That is why I was giving that example. We got sidetracked. But if you had only plus and minus, then you knew that this approach was easily going to work. But when you start to get multiplication and division, then that was not working. But with this current idea, we are transforming these pairs to nothing but the previous case, -2 into 2 is nothing but -4, right?
सुट्टी अब्बा आम्हाला कसं घरात बसून जास्त तास काम करावं लागतं.
Can you guys please mute yourself if you are not speaking?
Okay. So guys, is that clear? Gaurav, that's a very good idea.
Yeah, that's clear. Yeah.
That's really good.
Yeah. And this was the approach we were trying to go through. But I also like the previous idea. That is a very generic idea. So having a different stack helps. All right, guys. Okay.
Hello. Yeah, I have one idea. Maybe we don't need to use stack.
What do we not need? Stack?
We may not need to use the stack.
That's a good thinking. That's a good thinking again, because we are always now dependent on previous two values. So
right.
So that's the next jump, leap, that can we just keep getting those two values and try to optimize further. So you are right. Try to solve that, and I think that should work too. All right. So we have spent quite some time on this problem and we are left with one more problem. Should we do that next? If this is
Yes.
clear, okay. So let's do that. The last problem for the day. The last problem is what? Design linked list. So we have two design questions today. Okay, what are the functions? It's get, add at head, add at tail, add at index, delete at index. Okay. Yes, we record all the sessions, so we are recording this session as well. That was the question on chat, guys. So has anyone solved this problem? This is basically designing a linked list, like common linked list questions, like normal operations on linked list. So, and they are, I think, suggesting you can either use singly linked list or doubly linked list. What do you guys prefer to use, by the way? I'm just curious to know. Singly or doubly? Or it depends?
Most of the time depends, but I prefer doubly.
Okay, I also prefer doubly, personally.
I believe like the only interesting part here in this question is like getting by index.
Right. So I will just write it what we want to do. I think probably get index, and then there was add at head, then add at tail, and then add at index, and delete at index. And you will always have some values depending on what the function says. Okay. So also add at index is very generic. If you know add at index, then that should lead you to the add at tail and add at head already. Right? Because suppose if you have a linked list like this, it could be doubly, but for example, somebody is asking you to add at a certain index and you have this function already, somebody has written this. So if I have to add at head, I can pass to the same function argument 0. That will mean like, just add here to begin with. If I pass the same function a value of this length, then we are basically saying add at tail, right? So this function could be directly used by these two guys. So your core focus can shift to implementing this properly, like in a generic way. Okay, and then one thing I like about why I prefer doing doubly linked list is moving from both sides are easier, like you have both these pointers, so I can start moving in any direction. And you will see this kind of approach in other problems, like when you are you are designing LRU CAS. That's a very famous problem. If you have this kind of doubly linked list, it will help you. So the thing is now, how would we do this? Another good actually I would say useful trick in linked list question is use of dummy pointers. When you have dummy pointers, you can get rid of lot of edge cases. In this particular case, as such, we can say there is no dummy pointer, but actually you can think like you can always have these two ends as dummy pointers. We can call, hey, this is my head, this is my tail. Head, tail. And to begin with, like this could be like this. Before I start doing anything, I can have this inbuilt already, head and tail. Now, if somebody asks me, okay, insert something. So if I have to insert something, what I will do, I have to insert something here. We'll do those normal linking. Okay, do this, break this link, do this, and break this link. It's a couple of pointer exchanges. After that, it will start looking into this value. Like let's say it was 5, and let's say I just put -1 as my head and tail. So you will see this is -1, this is 5, this is -1, and now you will have this kind of structure already built. Here is my head. I will always have reference to head and tail. So is it clear so far? And is it also clear why this configuration will help me a lot?
Hello, Jimmy. Stay dry.
Guys, any question on this so far? This is, if you have used it, you will know. But if you haven't used, please give it think about it. This is a very useful thing. In this entire problem and other problems, having head and tail, start with building this relation to in the beginning itself will help you solve a lot of problems. Actually, a lot of checks you can get rid of that. Okay, so now after this, what you can do, as we talked about, add index is a very important function. So now if somebody says, okay, add something at index 5. Okay, now we have just added some value. I know there is no index 5 here. Ideally this is my only value. These two are my dummy values, which are my helper, which will help me to go from both direction. So I should also have something like some count of node somewhere. If I know my count of node is 1, and somebody is asking me to add something at 5, then I can say it's not possible. That's either we return some error, or we should return something like, okay, it's false or something. I don't know how they are asking me to return, or do nothing basically. Actually, in this case, it's void, so you do nothing. Okay. Now, suppose it's a good case. Suppose if it is a good case, then I can always start from here. I can start a runner. We'll go to the previous guy. We'll stop there, and we will insert a value in between, just like we did here. Exact same story. We can do that. So that way we would be able to solve this add at index. And if we have solved add at index, we already know that we have solved these two. If you want to optimize, then you can also do one check. Suppose your linked list length is, suppose, 1000, and you want to insert something at 998th position, for example. Then it's not ideal to start moving from this direction to this direction. Rather, since you have both this head and tail point fix, you can start moving from this direction. Just after 2 jumps, you will reach to that place, and then you will do the insertion in the same way, and you are done. It's like optimization, by the way. Similarly, delete at index. Delete at index, you can again do the same way. If you have to delete something, how do you delete? You go to this value, you should have always the previous value. Actually, it's a doubly linked list, so you don't even need to have previous value. So yeah, from here you can figure out the previous. From here you can figure out the next, and then you can just delete itself by unlinking this and let these guys link towards each other. So it's like simple linked list problem. Go draw it on your board, and then you should be able to solve it very easily. Only takeaway and what I like is try with this setup to begin with, and you will feel how easy it is to actually solve this problem if you start with this setup. Anyone has any idea or approaches or any question? We have 20 guys on the call. I'm looking at the participants. So let me know if there is any other question, guys, on this. This is a straightforward question, by the way, like implementation problem.
So, like how to find the index quickly?
How to find index quickly?
Yeah.
So
like this is a linked list, right? So we need to locate the node at particular index quickly.
yeah, so if you look at this like constant for this problem, I think the index value is up to 1000, right? So it's not a very, like, you don't have to optimize it. And what you are designing, again, you are designing just linked list. You are not designing something like LRU cache or something in particular where you need to optimize it, like, where having some configuration you need in O of 1 time. So it's okay to have O of n, like, lookups, or moving from this to this and this to this to figure out the place where you want to do this, like, insertion. That should be okay.
In that case, is a single linked list would be okay too, right?
Yeah, you can implement using singly linked list. Yeah, but I talked about a configuration where having this would help, like, like 998th plus doubly linked list helps me more because I can go both ways, like, left to right, right to left. So even solving this linking problems, I don't have to rely on always the previous guys. I can figure out the previous just by, like, being at any place, right? Because it is linked to both the guys, towards its left, towards its right. So implementation becomes easier if you have both the links. I would recommend try to solve it using both.
Yeah, I have a question. What his question is like how I find the quick index. So even we have both pointers, we have to traverse, right?
Yes.
Okay.
Yeah, we have to traverse. The only way you don't have to do is if you start something in a map somewhere, right? But then you will get into a tougher problem to solve. Now you have to maintain that mappings, right?
No, we can keep as a count, right? Whenever there is a link class we wrote, we can keep as a count as a variable. So the current count always means where is the pointer. Up to that, we can keep the count.
But then you are removing also, right? So you have to update all the subsequent guys.
Yeah, that's what I'm saying. In each function, get, add, head, add, tail, add index, and delete. all functions will update that count.
So suppose, like, I'm curious at this point of time, this was the case. So suppose we were just inserting, right? The problem you want to solve is a faster lookup, right?
Yes.
Okay. So what would I store for these guys? Like for A, B, C, D, E. So
Yeah,
suppose,
so count will be the, we can say like it's a part of the class variable. So it is it will be throughout the class available. So whenever we are adding, right? So in this case, the total count is 5. So 5 will be there. If it
okay,
is got deleted, then that count will get reduced. And if got inserted, whether it is head, tail, or index, anywhere, so the count will get increment.
that is right. I think we talked about that earlier. Like we were having also count to figure out why should I go from head side or towards tail to figure out the, like, this example. That's where I wanted to demonstrate that. But here the question is, if suppose I have to go to like some value 7, sorry, like 4 here, right? I have this configuration. This was 1, 2, 3, 4, 5. I have, this is count value, for example, right?
Yeah.
How fast you can make it? Like, so how where would you start from? You will still start from either this side or that side, right?
Yeah.
Right? So if you have 1,000 elements and somebody asks you for 500th, you will still go through
500.
either this way or that way.
Yes.
So it is still O of n, right?
Yeah, I agree.
But if we also keep a a pointer to the middle,
Okay. That's a very nice approach. Okay. So how much did we reduce it by? I think you will start building a skip list. Go and read this one.
I believe like we can keep a pointer to middle, but like what if we delete the first element, then that pointer need to be updated.
Yes, I mean, a lot of things will change. So if you are really interested, read this thing, skip list. Actually, that is based on, like, this thinking. It's a bit complex. I think it's also on lead code. So maybe someday we'll solve that problem for sure. But is this like, this was a simple design linked list problem for 1,000 nodes, and is at least basic approach clear?
Yes.
Okay. So don't start using map in this particular case. It's already simple case. But when we will do LRU case, then we will see how doubly linked list helps. Like, linking linked list, doubly linked list with map is very powerful. We'll solve some design problems based on that.
Roger, just a quick question. So we are updating, whenever we are updating at the head, we are updating, so at the front, we are updating our head, and similarly, when we are adding at the tail, so we are updating our tail as well.
So head and tail are basically dummy pointers. They are fixed. So they just, tell you where to start from. So in the beginning, you will have, like, those guys are linked to each other. And then as you start adding item, they start coming in between, but these guys are always fixed. And they allow a person, like, when you are starting, like, putting stuff at any place, they just allow a pointer, or let's call a runner, to start from either end, reach there, go and fix the link, and then just, we are done basically. So these are basically, yeah, go ahead.
So our list always starts from the, like, I'll say head dot next till the previous tail dot previous, like that.
Yeah, you're right.
Okay.
All right, so we are done for today. I think we are over time already, so thanks for your time. And
thank you, Roger.
Yeah,
thank you, Roger.
If you have a question, yeah, feel free to ask on the channel.
Thank you, Roger. It was a great session.
Thank you.
Thank you. Thank you, guys.